Hello everyone, welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. So let us move to the today's class. We are in the synopsis to permutation and combinations up to 14 problems completed. So we need to continue the problems and we need to start the synopsis 3 also today. Okay, right. So let us go through the permutations and combinations. Exercise problems. Okay, so let us start with problem number 15. That is given that the number of ways of arranging 6 red roses and 3 yellow roses. So 6 red roses and 3 yellow roses we need to arrange of different sizes into the garland. Whenever it is given that garland n minus 1 factorial by 2 we should take, or whenever it is given into the circular arrangement n minus 1 factorial. Okay na? Right. Such that no 2 yellow roses come together. No 2 yellow roses come together. Okay na? Right. How many yellow roses are there? 3 yellow roses and 6 red roses. So first of all, let us take that all arrangements of 6 red roses and 3 yellow roses. Right. So let us take that 6 red roses. How we are arranging in 6 red roses? In 5 factorial. Okay na? Because we are using in a garland, right? Or circular motion, circular way. 6 red roses can be arranged in 6 minus 1 factorial, nothing but 5 factorial. And also remaining no 2 yellow roses together. That means while you are arranging into 6 red roses like this, 1, 2, 3, 4, 5, 6. 6 red roses. In between there are 6 places for yellow roses. Here 1, 2, 3, 4, 5, 6. That means these 6 places should be occupied by only 3 roses. Am I right? That means 6p3. I told you already, whenever we use that garland word, we are using the formula for n minus 1 factorial by 2. I am arranging 6 red roses in the format of n minus 1 factorial. So denominator 2 also we need to take. Therefore the answer will be 6 factorial by 2 into 6p3. Why 6p3 came? Clearly given that the 3 roses should not be together. No 2 yellow roses should be together. That means there must be 1 red rose in between them. Okay na? So this is our required answer. 5 factorial by 2 into 6p3. So let us move on to the problem number 16. That is the number of numbers formed having not more than 6 digits. Not more than 6 digits. That means 6 digits we can take. 1, 2, 3, 4, 5, 6. It should not cross 6, but 6 we can take. Not more than 6 digits using the numbers 3, 4, 5. We should use the numbers 3, 4, 5. It should not more than 6 digits. So when repetition is allowed. Okay, right. So these 3 digits repetition is allowed for 6 digit number. How can we write this one? The first place can be taken with all 3 digits. Any one of the digit we can take. Same way, second place also 3 chances. Third place, fourth place, fifth place and sixth place. All are possibilities because we can take repetition here. So 3 into 3 like that 6 times, nothing but 3 power 6. 3 power 6. What is the value of 3 power 6? 3 power 6 value is nothing but 729. 3 power 6 value is 729. Here asking to make not more than 6 digits. That means we can take 6 digits, 5 digits, 4 digits, 3 digits, 2 digit, 1 digit number also. So we took 6 digit number. Now let us go to the 5 digit number. Same way 5-digit number can be occupied by 3 into 3 into 3 like that, because we are applying the repetition. So 3 power 5. So 3 power 5 value is 243. 3 into 3, 9, 9 3 is 27, 27 3 is 81, 81 3 is 243. Next 4-digit number 3 power 4, that means 81. 3-digit number 3 cube 27. 2-digit number 3 square 9, and 1-digit number 3 chances, that is equals to 3. When you add all of them, you will get the required answer. Okay, na? So let us try. 9 plus 1 10, 3 plus 7 10, 20, 29, 29 plus 3 32. So 3 plus 2 5, 5 plus 4 9, 9 plus 8 17, 17 plus 2 19. So this is 10. Nothing but 1092 numbers are possible by using this 3 digits 3 4 5. Okay, na? Right. So let us move on to the problem number 17. Yeah. So the 17th question, 20 persons are invited for a party. How many persons? 20 persons are invited for a party. The different number of ways in which they can be seated at a circular table. They can be seated in a circular table. For 20 members sitting in a circular table, 20 minus 1 factorial. N numbers can be sitting in a circular table, n minus 1 factorial. There are 20 members, 20 minus 1 factorial, nothing but 19 factorial. But the question is not yet n. That means with two particular persons seated on either side of the host. That means there are 20 people plus 1 person as host. 20 people and 1 person as host. That means total 21 people. On this 21 people, 2 persons are sitting only either side of the host. That means let us remove the 2 persons. So total 19 persons are there. These 19 persons can be arranged in a circular way. 19 minus 1 factorial. That is equals to 18 factorial. 19 minus 1 factorial, nothing but 18 factorial. And remaining 2 people either side of the host. For example, if you take the host here, that person can be seated here or here. That means 1 person having 2 chances, 2 ways into 2. So nothing but 18 factorial into 2 will be our required answer. Okay, na? 18 factorial into 2 factorial. Right. So let us move on to the question number 18. Okay. Yeah. Let us see. That is, a library has 6 copies of one book. One book having 6 copies. Okay. One book and 4 copies of each of 2 books. 4 copies of each of 2 books. So to identification, I am changing the color. So just identify each color represent each book. First book 6 copies. So second book 2 copies, each one 4. Next 6 copies of each of 3 books. 6 copies of each of 3 books. 6 each of 3. Okay. Yeah. And single copy of 8 books. Single copy of 8 books. Okay, na? Yeah. The number of arrangements of all the books in a linear shelf. Linear shelf. That means in a order. Let us identify how many number of books are there. So 6 plus 4, 10, 10 plus 4, 14, 20, 20 plus, 20 here. 20 plus 20, 40. So total number of books are 40, 40 factorial. These 40 books we can arrange in 40 factorial by how many are repeated? 6 factorial. Same book 6 copies. 6 factorial into 4 factorial into 4 factorial into 6 factorial, 6 factorial into 8 factorial. Okay, na? Yeah, each copies of each book, sorry, here, one copy, right? A single copy of 8 books. Single copy of 8 books, right? Now total how many are there? Total number of books are 40. So 40 books we can arrange it in 40 factorial. In that, what are they repeated? These 4s are repeated, these 6s are repeated. So we can take this one as 40 factorial by 4 factorial 2 times. 4 factorial into 4 factorial, 4 factorial square. Same as 6 factorial into 4. 6 factorial is appearing here 4 times. Okay, na? 6 factorial into 6 factorial or 6 factorial cube. So your option will be 2. 6 factorial into 6 factorial cube or 6 factorial 4 also we can write. Okay, na? Yeah, let us move on to the next one. Yeah, question number 19, that is given that number of ways can the letters of the word banana be arranged so that all A's come together. Here how many A's are there? 1, 2, 3. There are 3 A's. So total number of digits 6. So remaining digits are 3. So these all A's together taken as one unit, and this one 3. 3 plus 1 4. So this 4 we can arrange it as 4 factorial. In this 4 factorial, 3 A's are repeated, 3 factorial. 4 factorial and 3 factorial. Again in this n is repeated by 2 factorial. So 4 factorial into 3 factorial by 2 factorial will be our required answer. Okay, na? So the answer can be it seems. So let us check. So 4 factorial we can write as 4 into 3 into 2. 3 factorial is 3 into 2 by 2 factorial. And also when we arranging this 3 factorial, again all 3's are same numbers. Again they are repeated, so we can take 3 factorial again. Okay, na? 3 factorial means 3 into 2. 3 factorial, 3 into 2 cancel. Here 2 factorial means 2 into 1, 2 cancel. 4 3's are 12, 12 ways. Okay, na? Right. So just I am explaining one more time, check. So except A's, remaining 3 letters are there. 3 letters we are taking, and all A's together 1 unit, 3 plus 1 4. So these 4 letters can be arranged in 4 factorial, and in that 4 factorial again you need to check that repetitions. What are the repetitions here? N is repeated 2 times, so 2 factorial. And again in that 1 unit there are 3 A's. All 3 A's are repeating again together, 3 factorial. 3 factorial by 3 factorial can be cancelled, and 4 factorial we can write it as 4 into 3 into 2 by 2 factorial 2. 2 to cancel, 4 3 is 12. Okay, na? So let us move on to the problem number 20. Okay, right. The 20th one, if the letters of the word mirror, any repeated letters are there? There are 3 R's. Okay, na? Total 6 digits or 6 letters. In that 3 are repeated. Okay, or arranged in a dictionary. So then the rank of the given word. Rank you know how to find out. First let us write the given letters in alphabetical order. So first I, next M, O, last 3 R's will come. So these 6 letters are arranging in 6 letters. Let us use the first word I, and remaining places can be arranged into 5 factorial because there are 5 places. That means number of words begin with I, 5 factorial. But I we don't want, we want M. So next alphabetical word is M. So with M, first letter already we got it. M after again alphabetical order I we should write. That is also got it. Next alphabetical order O. So M, I, O, there are arrangement of 3 factorial. Next M, I, in the place of O, we can write R. Yes. Third place also we got. Next again alphabetical order O. O again we don't want, so 2 factorial. So again alphabetical order M, I, R, in the place of O after again R. So we found it. R after again alphabetical order O, last R, all arranged. This is 1 factorial. So what is the rank? Rank of this word equals to 5 factorial plus 3 factorial plus 2 factorial plus 1 factorial. 5 factorial, 5 into 4 into 3 into 2 into 1. Product of first 5 natural numbers, 120. 3 factorial 6. 2 factorial 2, 1 factorial 1. So 129. So what is the rank of the word mirror is 129. Here 9, here 120, 129. Okay, na? Right. So let us move on to the next problem. Okay. So 21st one. 3 boys and 3 girls are to be seated around a table. 3 boys and 3 girls are seated around a table, round table in a circle, nothing but a round table. So among them, the boy X does not want any girl as neighbor. There are 3 boys and 3 girls. So we can arrange like this: 1, 2, 3, 4, 5, 6. Total 6. 6 children or 6 people. That one particular boy does not want any girl as his neighbor. That means the boy must be sit with only the boys. So the boy I am taking as X or B1. Particular boy X not sit with any other 2 girls or any other girl as his neighbor. So beside right side and left side, remaining 2 must be boys until then. Okay. Next, yeah, and girl Y does not want anybody as neighbor of a boy. Y is a girl, she also does not want any boy as her neighbor. Okay, na? Right. So the number of such arrangements are possible. How many such arrangements are possible here? Okay, na? Right. So that means these 2 places, X and Y, these 2 places are fixed. Am I right? And B1, B2, these 2 must be boys because the person X only sit with the boys. That means we can arrange here B2 here and B1 here. That means B1, B2 having 2 number of ways. X value is fixed because he just sit between 2 boys, but remaining 2 boys can be interchanged, right? So B1, B2 having 2 ways, same way girls G1, G2 also having 2 ways. So 2 into 2, 4 ways. Okay, na? Such type of arrangements we can make it. Next, problem number 22. Okay. Yeah, let us check. So the number of ways in which 8 different stones can be strung to form necklace, so that 4 particular stones are never separated. There are 8 different stones. That 8 different stones, 4 be never separated. So these 4 can be taken as 1 unit, and remaining 4 plus 1 total 5 units. These 5 units are arranging in a strung like a garland. So formula is n minus 1 factorial by 2. That means 5 minus 1 4 factorial by 2 into, in this 4 all together can be sit like 4 factorial. Okay, na? So 4 factorial into 4 factorial by 2, that will be our required answer. Yeah, let us move on to the, okay, let us check the answer. 4 factorial means 24, right? 4 into 3 into 2 into 1. Here also 4 factorial means 24 by 2. So 2 table here 12 times. 24 12s are 24 into 12. So here 48 and here 24. So 288 ways. Okay. Your options are didn't given, so that's why I converted into the numbers, because the last answer is given as the numbers. Otherwise, we can leave like this: 4 factorial into 4 factorial by 2. Okay. So let us move on to the next problem. I think last problem from this exercise or synopsis. A 23rd one. The number of words that can be formed with the letters of the word Pataliputra. The word Pataliputra. P-U-T-R-A, right? Yeah. So without changing the relative positions of vowels and consonants. Without changing the relative positions of vowels and consonants. So first write the vowels. What are the vowels are there? Here A, so 2 times. I is a vowel. U also a vowel and A. So total there are 5 vowels are there. So how many letters are there actually here? 5 plus 6, 11 letters. In that 11 letters, 5 are vowels, remaining are consonants. 6 consonants. Consonants are 6, vowels are 5. Okay, right. Now we have to arrange them without changing the relative positions of the vowels and consonants, but they must be, words can be found with the letters of the word changing relative positions of the vowels and consonants. Consonant positions and vowel positions also we should not change. Okay, so consonants are 5, vowels are 6. So we can arrange them into 5 factorial into 6 factorial. Am I right? Yes. In this 5 factorial, how many vowels are there? 5 vowels. There are 3 A's are repeated. That means 3 factorial. Okay. In this 6 factorial, any repetitions are there? P. Yeah. 1, 2 P's are there. Let me write. T. Yeah, around 2 P's and 2 T's. L. And R. That means P's are repeated 2 times, T also repeated 2 times, so we can write it as 2 factorial into 2 factorial. Okay, so let us identify its value. So 5 factorial, I can write it 5 into 4 into 3 factorial by 3 factorial. Okay, same way, here 6 factorial, I can write into 6 into 5 into 4 into 3 into 2. Yeah, 4 into 3 into 2 factorial by 2 factorial into 2 factorial. Numerator 3 factorial, denominator 3 factorial cancel. 5 4s are 20. Now, numerator 2 factorial, denominator 2 factorial cancel. 2 factorial value 2, 2 table in 4 2 times. Okay, so here 2 into 3 6 and 6 5 30. 30 into 6 we need to take. 30 into 6. Right. So 2 into 3 6, 6 into 6 36, and here 2 zeros. So there are 3600 ways we can arrange Pataliputra as vowels and consonants with their respective positions. Okay na? So all 5 vowels I arranged in 5 factorial. All 6 consonants are arranged in 6 factorial, but in that 5 factorial, there are 3 letters, 3 same letter, a letter, same letter, repeated 3 times, so 3 factorial. In Pataliputra, there are 6 consonants, 2 letters are repeated 2 factorial and 2 factorial times. Okay, na? So, synopsis 2 completed. So, let us move on to the synopsis 3. I think it is based on the combinations, right? So, you know already the combinations we have discussed already in the binomial theorem. So synopsis 3. So mainly you should remember the combinations formula NCR equals to n factorial by n minus r factorial into r factorial. Okay, na? For example, if you take 5C3, how we are writing that? 5 factorial by 5 minus 3 factorial into 3 factorial, or there is another way also, that is 5 into 4 into 3 by 3 into 2 into 1. Okay, na? So 5 up to 3, 5 into 4 into 3, and there onwards 3 onwards up to 1 we should write in the denominator. Okay, so let us check both values are giving the same answer or not. 5 factorial value 120, 5 minus 3, 2 factorial value is 2, 3 factorial value is 6. So 6 to 12, that means nothing but 10. 5C3 value is 10. Let us check here. 2 table, yeah, 3 cancel here 2 times, 5 2s are 10. So both are getting the same answer, right? So every time to applying the formula like this, we can write easy manner like here. 5 4 3 by 3 2 1. Okay, right. And here we should remember 4 important points. That is, the first one is NCR plus NCR minus 1. First important point, NCR plus NCR minus 1 equals to n plus 1 CR. Example, if you want to take an example like 7C4 plus 7C3 equals to 7 plus 1 C4. That means 8C4. Check through the example. 7C3 means how can we write that? 7C3, 7 into 6 into 5 into 4 by 4 into 3 into 2 into 1. Plus 7C3 we can arranging like 7 into 6 into 5 up to 3 numbers. Here 3 is given, up to 3 numbers we should decrease. Okay, right. Here see up to 4, 1 2 3 4 numbers we decreased. Here 3 numbers, 1 2 3. Now here 3 into 2 into 1. Let us try to cancel it here. 3 2s are 6 and 6 cancel. Denominator 4, numerator 4 cancel. 7 5s 35. Now this one. 3 2s are 6, 6 cancel. This is also 35. 35 plus 35 value is 70. Let us check that RHS part rate. So 8C4, 8 into 7 into 6 into 5. 4 numbers completed. 1, 2, 3, 4. 8C4 up to 4 numbers we should decrease. Now here onwards 4 into 3 into 2 into 1. 4 2s 8 and 8 cancel. 3 table here 2 times cancel. 7 into 2 into 5. 5 2s 10. 10 into 70. 7 70. So both LHS and RHS are equal. So NCR plus NCR minus 1 equals to n plus 1 CR. That is the first important point. And also we know what is n factorial, product of first n natural numbers. And also we discussed in our previous classes like 0 factorial value 1 as well as 1 factorial value also 1. Now first point is over. Now second one. The second one is nothing but NCR equals to NCS. For example, if you check that NCR is equals to NC5, there are two conditions like R value must be equals to 5, R equals to S, or R plus S equals to N. Okay, now here if you check that NCR is equals to NCS, the first situation R equals to S or R plus S is equals to N. These two R should be satisfied by the given combinations NCR. Next, third one. Now third note point is NCR equals to N by R into N minus 1 C R minus 1. This is also very important point. This one we can write in another way, that is NCR by N minus 1 C R minus 1 equals to N by R. Like this also we can write. That is the third important point. Let us move on to the fourth point. Yeah, the fourth point or fourth node point is given that NCR by NCR minus 1. NCR by NCR minus 1 equals to N minus R minus 1 by R. N minus R minus 1 by R. Okay, na? This is also important formula or node point. Right. So let us move on to the exercise problems or concept based questions first. Then further discussions we can continue in the next class. Okay. So first practice sheet problems. Yeah, practice sheet problems. Right. The first one is if NC21 equals to NC27. First one, NC21 equals to NC27, then N value. So just now we have discussed that the second important node point NCR is equals to NCS. Then the condition R must be equals to S. R and S must be equal, or else R plus S is equals to N. But while you are checking here, R value and S value not same, both are different here. 21, 27 both are not equal. So second condition is R plus S is equals to N, right? That means 21 plus 27 equals to N. 21 plus 27 is nothing but 48. So N value is 48. So let us move on to the second problem, second concept based question, that is 12CR is equal to 495. 12CR equals to 495, then R value. So first of all, we need to do the prime factorization of 495. I am doing here 495 prime factorization. I am taking 5 table. So 5 nines 45, 5 nines 45. Now 11 table, 5 nines or 9 ones. So this 495 we can take it as 5 into 11 into 9. So 12CR. That is equals to 12CR. 12CR means 12 factorial by 12 minus R factorial into R factorial. That means the 12 must be there. Or if you want to write like 5C4, like 5 into 4 into 3 into like here 12CR also 12 into 11 into 10 into up to R. R can be 1, 2, 3, 4, any number. Okay, same way. So here 12 will be there. Here also 12 must be there. So for that I am just multiplying divided by 12. Okay. So then I am writing in order 12. Yes, this 12 will be there. 12 after I need 11. 11 also there in the prime factorization. So I can take 11. So 11 after what we need? 10. But here 10 not there. But 10 related 5 will be there. If you multiply and divide it by 2, 5 2s are 10 will be. So let us multiply and divide it by 2. Then 5 into 2 we can take it as 10. And what is remaining? What is remaining? 9. So 12 into 11 into 10 into 9 divided by 12 into 2, 24. 24 also we can write it as a prime factors of 2 12s, 2 6s, 2 3s. So 3 into 2. 3 into 2 into 2 into 2, 4. So 4 into 3 into 2. Am I right? So simply we can write it as 12C4. This is nothing but 12C4. 12C4 means 12 into 11 into 10 into 9 by 4 into 3 into 2 into 1. 12C4, or we can write it as 12C8 also. How it will be 12C8? Yeah, here we forgot to discuss one point, that is NCR is equals to NCN minus R. What is that important point? NCR equals to NCN minus R. For example, 7C3 is equals to 7C 7 minus 3. Am I right? According to the formula. 7 minus 3 means 7C, 7 minus 3, 4. That means 7C3 value, 7C4 value, both are equal according to this node point. Let us check. 7C3 means what? 7 into 6 into 5, 3 numbers. Here 3 will be there in the suffix. So up to 3 digits we have to reduce. So 3 into 2 into 1. So 7C4 value how much? 7 into 6 into 5 into 4. Up to 4 numbers we should reduce. And here 4 into 3 into 2 into 1. Now 3 2s are 6 and 6 cancel, 7 5s 35. Now what about here? 3 2 6, here 6 cancel, numerator denominator 6 cancel, 7 into 5 35. See, 7C3 value, 7C4 value are same because it is following the condition like NCR equals to NCN minus R. NCR equals to NCN minus R. Okay, so let us move on to the next question, that is 12. Yeah, 2 questions completed, right? Yeah, third question. Third question, the number of ways of forming a committee of 5 members from 5 men and 3 ladies or 3 women. 5 members committee we need. From this 5 members committee, we should take 5 men and 3 ladies or 3 women. From these 5 men and 3 women, total 8 persons are there. From these 8 persons, we should make any 5 members committee. How can we make the 5 members committee? That means, now first there are multiple choices, like from the 5 members, I can take 1 male and 4 female, like that. So let me try to write. From the 5 men, 1 man I am selecting, and from 3 women. So total we should get 5 members, right? If you take only 1 man, there is no chances of 4 women. So there is no chances of 4 men. So we should take 2 men. Then 2 men, 3 women we can take. So 2 plus 3, 5 will be satisfied. Or 3 men, 2 women. Or 4 men, 1 woman. Am I right? Or one more chance also, all 5 men. There is no woman here. Right, 5C2 value how much? 5C2 value 5 into 4 by 2 into 1. Okay. 3C3 value, NCN value, NC0 value, both are 1. Plus 5C3 and 5C3, 5C2 are same, right? Because NCR is equals to NCN minus R. So it is also, we can write 5 into 4, or else you can directly write 5 into 4 into 3 by 3 into 2 into 1. And 3C2 value 3 into 2 by 2 into 1. Plus third term, 5 into 4, NCR, NCN minus R both are same. So we can write it as 5C1, so nothing but 5. So 3C1 value is 3, 5C5 value 1. Okay. Now 2 table here, 2 times 5 2s are 10 plus numerator 3, denominator 3 cancel, 2 table in 4, 2 times 5 2s 10. See, I told you 5C2 value, 5C3 value both are same. And into 3 plus 5 3s are 15 plus 1. Add all of them. So here 10, here 30, 40. 40 plus 15, 55 plus 1, 56 ways we can make them 5 members committee by using 5 members and 3 ladies. Okay. Or directly, yeah, sorry, it is directly given. It is not mentioned that particularly one person, at least 1 male are there, at least 1 female are there. It is not given like that. So directly from these 8 persons, 5 we should take. 8C5 will be our required answer. So this is the solution for at least 1 male or at least 1 woman. Like this condition is given, we can use this method. So here condition is not given, so sorry for that. So 8C5 we can take like that, okay, directly. So question number 4. Yeah, question number 4. If NPR is equals to 720, NPR value is 720 and NCR is equals to 120, R value we should find. NCR equals to 120, then R value is how much? Okay, so let us check that NPR, NCR different. NPR formula n factorial by n minus r factorial, that's it. This value 720. But NCR value n factorial by n minus r factorial into r factorial. This is 120. Both I divided, okay na? So, two fractions we can apply the reciprocal 120 in 720, 6 times cancel. Okay, so remaining next n factorial by n minus r factorial, and the denominator fraction when you take it to numerator it will be reciprocal. So n minus r factorial into r factorial by n factorial. So factorial numerator n factorial cancel, n minus r factorial cancel. So r factorial is equals to 6. So 6 is nothing but 3 into 2. 3 into 2 into 1 are 6. Nothing but r factorial is equals to 3 factorial. Therefore, r is equals to 3. R value will be 3. Okay, na? So let us move on to the problem number 5. Yeah. Problem number 5. That is given that. So 15C3R equals to 15C3R is equals to 15CR plus 3. 15CR plus 3. We need to find the R value. So just now we discussed a condition like NCR is equals to NCS. There are two cases it is possible where R is equals to S or R plus S is equal to N. Same way I am using the second condition, R plus S is equals to N. So from that I can take 3R plus R plus 3 is equals to 15. 3R plus R, 4R. 4R plus 3 is equals to 15. Plus 3 transpose that side becomes minus 3. 15 minus 3, 12. So R is equals to 12 by 4. So R value is 3. Okay, no? R value is 3. Or if you take the condition like R is equals to S. R is equals to S. What is the condition here? 3R is equals to R plus 3. Bring all the variables one side, numerical one side, plus or bring this side minus R. 3R minus R is equals to 3, 2R is equal to 3 because 3R minus R. Then R value 3 by 2. But R cannot be in the fractional form. So we have to consider only R value is 3. So let us move on to the next problem, nothing but sixth one. Yeah, sixth one. That is NC5 equals to NC6. NC5 equals to NC6. Then what is the N value? 5 cannot be equal to 6. So according to second condition, R plus S is equal to N. So 5 plus 6 is equal to N. N value 11. So what we have to find here? We have to find NC5 minus 13CN. NC5 minus 13C N value we should find. But from the given condition, what is the given condition here? NC5 equals to NC6. According to this value, R plus S is equal to N. 5 plus 6 is equal to N. So N value 11 we got. Now substitute here 11C5 minus 13C11. 11C5 value. 11C5 value 11 into 10 into 9 into 8 into 7. Up to 5 digits we reduce 1, 2, 3, 4, 5. Next here 5 onwards. 5 into 4 into 3 into 2 into 1 minus 13C11 we can write as 13C2 because of the formula NCR equals to NCN minus R. So from this 5 to 10 here 10 cancel. 3 table in 9 3 times cancel. 4 table in 8 2 times cancel. The remaining is 11 into 3 into 2 into 7 minus 13C2. 13C2 is nothing but 13 into 12 by 2 into 1. Here 6 times cancel. Okay. So now the 11 into 3 33 into 2 7s 14 minus 13 6 are 78. So 33 14s. 33 14s. So 4 3 is 12, here 4 3 is 12. Nothing but 462. 462 minus 78. So that is equal to 13 minus 8 is 5. Here 5 minus 7 not possible. Here 8, 385. So our required answer will be 385. Sorry, 84. Yeah, this will be 12, right? Yeah, 84. 384. Okay. So last one. The number of ways of forming a committee of 5 members. Now the question came. Committee of 5 members. Committee of 5 members from 6 men. 6 men and 3 women. And the condition is given that the number of committee contain at least 2 girls or 2 ladies. 2 ladies we must take at least 2 ladies. So from this 3 we should take 2 ladies. So 3C2 into total how many members we should make? 5 members. So already 2 we used. So remaining 3 members from 6 men. 6C3. Next all girls. 3C3 into 6C2. Any other options? No. At least 2 women means these 2 conditions we should use. Next. 3C2 means 3 into 2 by 2 into 1 into 6C3 means 6 into 5 into 4 by 3 into 2 into 1 plus 3C3 value 1, 6C2 value 6 into 5 by 2 into 1. Let us check. So numerator to denominator to cancel. Here 3 into 4 5s are 20. Now here 2 table here 3 times cancel, 3 times are 15. 3 5s are 15. Okay, no? So 3 into 20, 60 plus 15 is 75. So there are 75 ways we can arrange by using at least 2 women. Okay, no? So that's it for today, children. Thank you one and all. Have a nice day.